Hi everybody, my name is Dan Boyle, Sales Support Specialist here at OPW. Today we're standing in the Smithfield, North Carolina OPW Retail Fueling Manufacturing Facility to go over some of the EVR or Enhanced Vapor Recovery highlights to go along with part of our training and certification course. It's very important to note that this video is not a substitute for that training or test. This is to go along to show some visual representation of some of the most important part of our manual for EVR. As you can see, I'll be standing here today next to a cutaway fiberglass tank, so my safety is going to be very different than your safety. You're going to have large machinery, very likely a big deep hole in the ground for these tanks to set in. I don't have any of that, so I have no PPE, but you're going to have to follow any OSHA requirements, local requirements, or requirements set up by your own company. So with that, we'll get into our sections of our EVR manual. So I'm going to go through this step by step. We're going to show, you're going to see some similarities, especially among buckets, but there are some glaring differences that we're going to highlight as well. So with that, let's get into section 1. So what EVR, or Enhanced Vapor Recovery, is the capture of fugitive emissions during the transfer of fluid into a UST tank with a minimum efficiency of 98%. Section 1 focuses on the 2100 series thread-on spill bucket. It's very important to note that no slip-on containers are allowed by EVR compliance rules. Second, that any place where fuel or vapor is being dropped or removed from the tank must be done within a spill container. So our first one we're going to cover is the 2100 series bucket. The 2100 series bucket has been around for a really long time, and there's a couple of things that you need to do differently with the 2100 than you're going to need to do with either the 3100 series or the 2200 series. The first and most important thing will be this FSA-400, which is a face seal adapter. Now, because we're trying to contain all of those emissions, we don't want them leaking out through through various openings within the tank or any of the equipment housed within those openings. So the face seal adapter's purpose is to give a machined surface seal to either a 61 SO or a 71 SO overfill prevention valve, whichever one you might be using. It's also important to note that the 2100 series comes in a composite base as well as a cast iron base. There are some small differences between these two, namely that the face seal adapter you use for one is not the same that you use for the other. We're going to be threading on a composite 2100 spill bucket today, so we're going to be using the FSA 400. If you're using a cast iron base, you can use the FSA 400S, which is a shorter face seal adapter. So you have your tank here, and the first thing we're going to install is going to be our riser. Your riser is probably going to be a bit taller than this. So we're going to thread this in. It is important to use a fuel and oil compatible soft set non-hardening sealant for these threads. And once we get our riser in there and we need to start torquing it down, now is the first time you're going to hear me talk about torque stack, which you're going to hear another 20 times throughout this video. Essentially, torque stack means that from the bottom up, we want to make sure that the things below are more tight than the things above them. So for this riser, we have a recommendation of 125 to 200 foot-pounds that needs to be tightened on here. Because it's the first fitting, we're going to want to go towards the top end of that, so 225, 250. We want to make sure that this riser never spins out if we ever have to do work in the future. So to do that, we'll use our TC400 tool. We're going to put that right on top. This has threads that will allow it to come off once this is tight. So we'll put it right on there. We'll get our 61 SA tool, and it has provisions to fit right over the top of those ears. So once we have this, our 61 SA tool on top, this has a 7/8 inch nut on top where you can put your torque wrench. Through the entire process of EVR, the torque specs are incredibly important, so it's necessary to have your torque wrench. You're going to put this one on, like I said, you get that one probably close to about 230, 240. You want to make sure that that thing's not going anywhere. So once we get that on, we're going to get that nice and tight. We're going to put it back the other direction just so we can knock it off those threads. Remove your 61 SA tool and unthread your TC400 cap. So from here, remember I said we're going to be using a composite base, so we're going to be using the tall face seal adapter. The face seal adapter will go on here next. Again, you're going to want to use that fuel and oil compatible soft set thread sealant. You're going to put this on. Our 61 SA tool will then go right back on top of that face seal adapter, and we'll bust our torque wrench back out just to make sure that we get this tightened down. Now, if we had done the riser at 240 foot-pounds, that means we're going to put this face seal adapter just less, so 230, 225. Now that we have our face seal adapter, this is going to be the spot where the spill bucket rests, and once the spill bucket is on and it's time to install our overfill valve, this is going to be the machine surface where that seats. So very next, we'll start to spin our cast iron base, or I'm sorry, our composite base onto our face seal adapter. And from here, we're going to again use our 61 SA tool, but this time we're going to flip this thing around and just use this piece right here. So with this 61 SA tool, we're just going to remove the hardware to take our 7/8 inch hex nut out of here. We'll put that part of the 61 SA down, and then it's this bolt through here. You're going to remove this to remove that hex nut, and you're going to flip it around to put it on the bottom. This is going to kind of reverse which direction we're using on this thing, and this has provisions inside that 2100 spill bucket to slide down inside a slot and to give you a place to put your torque wrench right on top with an extension to tighten that on there, and I'll show you what that looks like in this bucket. So now we've got the first three pieces installed of our 2100 series thread-on spill bucket. We've got our riser, we've got our FSA-400. Since we're using the composite base, if you're using the cast iron base, you could go with the 400 FSA 400S, which is a shorter version. The next piece is going to go in, and this is going to make sure that our overfill protection is vapor tight. Because we're using this composite base, I will be using the 61 JSK-4410. If I were to be using the cast iron base version of the same spill bucket, I would use a different jack screw kit, and that would be a 61 JSK-44CB. That CB, of course, stands for the cast iron base. So we'll set this down on our face seal adapter, and that will be a placeholder for once we're complete and it's time to set our overfill prevention. It will go then underneath that jack screw kit to seal on that face seal adapter. The next piece that we have to install is going to go on top of that jack screw kit, and that's going to be our nipple. So our nipple is going to go in. So all four of these pieces to this point, our riser, our face seal adapter, our spill bucket, and our nipple, all set within that 125 foot-pound to 250 foot-pound recommendation for installation for torque spec. If we said we had 240 here, 225 here, 215, 200 on the spill bucket, then we'll probably come up under this nipple and we'll do about 175. Here again, any of our threaded components, we want to use our TC-400 tool to tighten that on. So we get that on. We'd use again our 61 SA tool, and then use our torque wrench to make sure that we are getting proper torque on this nipple. So once we've got our nipple installed, the last piece that we're going to put inside this spill bucket is going to be our fill adapter. The fill adapter is also going to be installed with the 61 SA tool, and it threads right on top of that nipple that we just installed. The fill adapter is going to have a different torque spec than the previous four pieces that we've done. This one is 90 to 110 foot-pounds. Once our fill adapter is installed, that is a complete installation of a 2100 series spill bucket. Next, we're going to continue on to section 2 for the 2200 series, which is the installation of our 2200 spill bucket. There are some similarities and some differences here between the 21 and the 22, but most similarly, they are both single wall containers. So with the 2200 bucket, The first thing and the most important difference in the installation is it does not require a face seal adapter. The FSA 400 or the FSA 400S does not apply to this bucket, as with both of our newer models, the Edge double wall bucket and the 22, we have installed actually in the base a machined face seal adapter where your overfill valve will sit without having to add any extra pieces. So with this, we're still going to have the same installation practice where we're practicing our torque spec, our proper torque stack. That's going to be towards the higher end of the 125 to 250 for our riser, and then for our spill bucket, because again there's no face seal adapter needed, then we're going to spin this on as well to just above or just slightly less than what our riser was. Now the second big change for the 2200 bucket was it does not use the 61 SA tool. Instead, it uses the 1-3100 tool. So the biggest difference with this tool and the other is where it seats, where our provisions were for some of our other tools on the 61 SA. The 2200 bucket features a 3-bolt flange to remove the nipple and fill adapter, which we'll go into in just a second. So when this sits down on the inside of this bucket over that 3-bolt flange, you can see how this sits so that you can get a bite on this to put on your torque wrench. So once you've threaded on our 2200 spill bucket with the 3100 tool, I just want to go into a couple of the features of that 3-bolt flange as they apply to EVR. So first, it's really nice whenever you have to check, let's say, the operability of a 71 SO or an overfill prevention valve down in your bucket. Rather than spinning off all of those, the nipple, the fill adapter, rather than spinning those off and running the chance of someone who didn't properly torque stack and maybe they spin out the bucket or maybe the riser starts to spin, we've gotten rid of that happening at all with this 3-bolt flange. You can remove those 3 bolts, and that entire assembly, that 3-bolt flange, comes out and removes your nipple and fill adapter and cap, so it all stays one piece, which gives you access then to your 71 SO, your jack screw kit. Whenever you do pull that out and you go back in, you want to make sure that first, prior to pulling it, you've cleaned out the bucket so there's not a lot of waste or debris in there. But certainly whenever you go back in, you're going to make sure that that O-ring is greased well, it's shoved back in, and that those 3 bolts are tightened to 20 to 25 foot-pounds. So the reason that we came up with the 2200 bucket was for replaceability purposes. Everything in the spill container can be replaced without breaking concrete. We've got 8 bolts down in the bottom, which you saw. Those are removed along with 8 bolts in the top ring. Those are removed, and these bellows simply slide out and allow a new container to be dropped in. That will replace the bellows should this spill bucket ever fail. The top bolts around the ring here for this bucket will be at 15 to 20 foot-pounds. So once we've got our bucket installed, our 3-bolt flange is in there, the next thing we're going to do, just like the other buckets, is we're going to install our 71 JSK, and that's going to seat down inside on that face seal adapter, which we install here at the plant. Remember, there is no face seal adapter on this bucket. And then our fill nipple will go right inside on top of that. And again, we're going 125 to 250, less than the component below it. And we'll use that TC400 cap and a 61 SA tool to install this. So with our nipple in, the last piece to go on top will be our fill adapter, which again we're using our 61 SA tool. One of the most obvious differences between our 2200 bucket and either of our other spill buckets is the perceived lack of a plow ring. You can see that we've removed the plow ring from the actual spill container itself, and we've moved that function into our symbol of a lid. This is a pretty heavy cast iron coated lid, and it will allow deflection of a snow plow blade, just like the replaceable plow ring will, with this heavy lid, and will resist coming off. So another thing that this design allows us to do is, whenever it's time to test this spill bucket, we've created the SC-test, which should look very familiar to you. It is our sealable cover, but we have actually made a small change where we've tapped in a test port that's the exact same as our double wall edge. That's the always present interstitial test port for the edge. So with this, you can latch down the SC-test, and using our same vacuum pump that we use for all of our other vacuum tests, you can stick that right on here and you can actually run a vacuum test on this single wall bucket. That now takes the testing time from 1 hour to 5 minutes. Do make sure that you check with your local regulators. I know there are some areas out there that still require the hydrostatic testing of this spill bucket, but where allowed, please do use that SC-test, which makes for a quick, easy vacuum test. So as a quick summarization, the 2200 bucket, very similar to the 21, except we are going to be using that 3100 tool instead. It does not require the face seal adapter, the FSA 400, and you can vacuum test that. So we're still going to do our same torque stack from riser to spill bucket to nipple, and then that fill adapter will go on there at also 90 to 110. And that's the complete installation of a 2200 series. So now we'll jump into section 3, and that is the 3100 series single wall spill bucket. I'm actually standing here next to the double wall version of this bucket, but we're actually going to be talking about the single wall version, which is boop, right there. So essentially we've taken the 2200 spill bucket and made it into an envelope where you can install it as a single wall bucket, and should ever the end user or regulation or any of the above ever push you into double wall compliance, you're able to do that without breaking concrete. And the way we do that is we essentially take the 2100 series spill bucket, which with its base and its bellows, and we mount it up with the envelope of the edge. So you're still going to have your cast iron base, and you're still going to need your FSA-400S. Because this is cast iron, we're using the short version. So when you install this on the riser, you're essentially taking the place of the entire envelope should you ever need to put a double wall container in it. You'd spin out the cast iron base of the 2100 and the face seal adapter, and then you could go right back in with the double wall cartridge. The face seal adapter stands to take the place of this secondary here, so whenever you take this out, you have room to go back in with that double wall. Now there's a couple of interesting pieces that go along with this for the installation. As always with the other buckets, we're still going to practice that proper recommendation of 250 towards the bottom, towards the 125 at the top, and that's going to go on with our riser, and then we're going to put our face seal adapter, and then we're going to spin on the 3100 edge 1. Now, to do that, we're still going to need that 61SA tool. If you remember, we went to the 3100 tool for the more recent model, but because this is utilizing that 2100 series base, we're going to go back with our 61. So with our nipple, our FSA 400S, and our 3100 Edge 1 bucket on there, there again, going with our proper torque stack. The only thing that's left is to install our jack screw kit, which is going to go right down inside that bucket and rest right on our face seal adapter. And then we can go back in with our nipple, which is going to be installed with our TC-400, and then we can put our fill adapter on after that, same as we've done from this point forward with our other previous buckets. Should we ever need to go from that single wall to the double wall protection, it's important to note that we are using different cast iron bases once you step into that double wall territory. So once you get into the edge double wall, you'll actually be using the 3100 tool for most things, as it has the provisions to fit over that 3-bolt flange. It still will be necessary to use that 61SA tool though on your nipple and also your fill adapter. Moving into section 4, we'll be covering the 3100 series double wall spill containers. For us, that's the OPW double wall edge. This is the piece de resistance of all of our spill bucket product line, and I'd like to go through a couple of those features with you real quick just to show you why. So for one, with the newish EPA regulations out, with overfill operability checks, with every 3-year spill bucket containment tests and integrity tests, this spill bucket along with the 22 do a really good job of making some of those tests really easy to do. With our 3-bolt flange, you can remove to get to that overfill valve easily. Every piece within this bucket is essentially replaceable, from the primary containment, the secondary containment, the seals that sandwich the two together to create that top seal, along with the snow plow ring. Every piece of this can be replaced, so you don't have to go all in and buy a new spill container should ever the day come when one of these components fails. The spill bucket also contains our permanent interstitial test port. Where with our vac tool, you can just hook up to this, you can pull a quick 5-minute vacuum, and that will actually test the primary and secondary of this spill container. So that gets you a quick passing test in about 5 minutes. So just like we've done in our previous installations of our spill buckets with the 21, the 22, and the 3100 single wall, we're still going to install that tank riser to the torquier end of that 125 to 250 foot-pounds. Then we'll spin on our double wall edge bucket, just slightly less torque than the component below it. And once we're there, we're ready to drop in our 61 or 71 JSK, which will provide the pressure needed to seat that 71 SO down onto the built-in face seal adapter that is in this spill bucket. So once we have our jack screw kit, we'll go back in with our nipple, which we'll put on the TC400 with our 61 SA tool, and then we'll go on with our 61 SALP or our fill adapter, also using that 61 SA tool. Just a couple other items of note while we're talking about the double wall edge container. You see this one here has a Visi gauge. This is just a visual representation with a float on the bottom that shows you if there's any liquid in the interstice of this bucket. Should this be reading that you have some liquid, you can easily remove this Visi gauge, and you're going to want to go in there with a copper tube and a proper vacuum or a proper hand pump to remove any of the liquid that you see in there. We do sell this with multiple other types of sensors. The edge spill bucket does come in a number of different models. It comes in the 3112, which is the model that we're working with a Visi gauge, the 3122, the 3132, and the 3142. I will illustrate the differences in these. The 3122 comes sensor ready, which means it has the access port and an available spot for a sensor, but it doesn't actually come with a sensor. The 3132 is used with the OPW sensor and can be used with OPW ATGs along with other ATGs on the market. The 3142 is designed for the use with the Veeder-Root ATG. And also, as a reminder, as I said, everything in here is a replaceable part, but anytime we take off the snow plow ring, anytime you remove the 3-bolt flange, or anytime you remove the Visi gauge, those all have gaskets or O-rings. We want to make sure that we have a clean area to seat those, that we clean anything off, and we re-grease those O-rings to slide those back in. So for this iteration, I'm standing next to our visual gauge style, the 3112D, because it has a drain. This is just a very basic reference where if there were to be any liquid in the interstice of this bucket, it would move the needle. And that needle moving would let you know that you need to get in there to remove it or at least investigate. How you would do that is you would just spin out this visual gauge, and you can go back in there with a copper tube and a proper vacuum to remove any of that water as necessary. We do also sell this bucket in the other options, which I'll go through in just one second. But as far as replacing components of the bucket itself or replacing sensors as it applies to either our visual gauge or our electronic sensor, you can go watch yours truly on a different spill bucket video that will give you all the in-depth steps on how to take care of replacing those components. Section 5 covers our 700L series. Just a quick note on that. We do still sell all of the replacement components for the 700L with the exception of the fiberglass secondary. Should you need to replace the secondary of that, we do actually make a 3700 insert, which essentially gives you the double wall edge cartridge that drops into a retrofit package that we have made for the old 700 buckets. So now we're ready to jump into Section 6. Section 6 is going to cover our drains and our plugs that go in the base of our spill containers. We actually have two styles of the way these are mounted. You're either going to have the cast iron base, which has two bolts that thread directly into that cast iron base, or like we did earlier with the 2100 with the composite base, you're going to have two studs that protrude from that bucket, and you just need to remove the nuts off of those. Prior to pulling out this drain or a plug for any reason, you're going to want to make sure that you get in there and you clean this spill bucket. There might be debris, there might be a little bit of residual fuel or water. We want to make sure we get everything out, so when we pull this drain or plug, that we're not getting anything that's seeping down into the tank. So after we remove those 2 bolts, you're just going to pry this from its seat, and this is what that drain valve looks like. This O-ring is a very important piece, and whenever you remove it, you want to make sure that you've got this piece to come out, because when we go back in with either a new one, we're going to make sure that we put some moly grease on this O-ring, and we're going to make sure that that goes down back inside. This is the plug version of our drain, should a drain ever need to come out and that hole be filled. You can see it's the same O-ring. Again, make sure we grease that, and we're going to push that back in. We're going to seed that until it pops. We're going to kind of feel that kind of take its seat right where we want it to, and then from that point you can go back in either with the nuts or the bolts, and you're going to go to 11.5 to 13.5 foot-pounds of torque on those bolts for the drain and the plug. It's very important here that this drain can be used in EVR spill buckets. It can never be used in vapor buckets. So the plug is what we're going to want to see inside those vapor recovery spill containers. That covers section 6. As we get into section 7, we're going to be discussing 6500 series Multiport spill containers, as well as the 6511-RB16 riser spacer. The only purpose that this riser spacer serves is that when you're bringing up those 2 risers from the tank top, this is going to give you your 16-inch on centers. It's going to make sure those are nice and squared up, so that when we spin our spill buckets on and we put our top on our at-grade lid, everything lines up with those 16-inch on center. Easy for me to say. It's important to note that because this is a different style of container, we still are going to spin our spill buckets onto that 125 to 250 pound torque, less than the riser below it. Just because it's going to be underneath a multiport, there is a different series of installations that we do need to do, but that still needs to be torqued on the same. And then the bolts, or I'm sorry, the nuts that connect the ring at grade to your spill bucket, those are going to be torqued down at 15 to 20 foot-pounds. With that, I'm going to kick it over to Jim Goodman, who is the man of all things Multiport and Fiberlight.
First, let's review our recommended installation practices. Follow all appropriate health and safety requirements and use appropriate personal protective equipment or PPE. These instructions include these symbols when PPE is required. Use cutting tools that are designed for use on fiberglass or composites. Failure to use appropriate cutting tools or blades may damage the fiberglass tank sump parts and result in a poor installation. Store all resins and adhesives used during the installation process in a warm and dry location until ready for use. The internal temperature of all resins and adhesives during installation should be between 60 degrees and 70 degrees Fahrenheit at the time they are used. Surface preparation is critical for the application of fiberglass and adhesives. Any fiberglass surfaces that will be fiberglassed or bonded will require that the sanding sufficiently exposes the surface fibers. Failure to properly prepare surfaces prior to the fiberglassing or bonding may result in a poor or leaking joint. Use acetone and clean rags to clean any prepared surface. Failure to clean surfaces prior to bonding may result in a poor or leaking joint. Now let's join Jim Goodman as he reviews the entire procedure for installing the Fibertide Multiport.
All Fibertide Multiports are shipped as complete kits with all of the necessary parts required for installation. Some kits include OPW Fiberlight tank sumps, while other kits are designed for installation onto a tank manufacturer's sump base. It may be necessary to order fill and vent adapters as well as fiberglassing kits separately. To ensure you have ordered all of the required material, please contact your local OPW distributor prior to placing your order. Inspect all parts upon delivery to ensure they have not been damaged during shipment. Each fill sump kit should include all of the parts and adhesive kits shown to the left. Store parts carefully to avoid damage on the job site. Do not store sump bases on their sides. This can cause them to oil can. Take special care with the sealants and resin kits, as prolonged exposure to excessive heat can cause them to crystallize. The Fibertide Multiport kit will not work properly unless it is installed as shown in this dimensional drawing. Regardless of what manufacturer's sump base is being used, The top of the Fibertide top hat must be installed so that it is 10 to 12 inches from finished grade. Finished grade is defined as the level at which the top of the multiport frame or cover will be installed. This may be 1 to 2 inches above the tank pad level to allow water to drain away from the cover. Check this dimension by running a string line at finished grade and dry fitting the top hat onto the sump base. Measure down from the string line to confirm the 10 to 12 inch distance. Installing the top hat too low may make it difficult to install the shroud boots and thereby properly seal off the spilled buckets. Installing the top hat too high may make it difficult to install the multiport cover into the frame. Please contact OPW Technical Support if you have any questions or concerns during installation. Once the sump bases have been properly installed, the fill and vent risers can be cut and threaded into the tank bungs. The fill and vent risers will need to be cut to the proper length so that the top of the installed P761 spill buckets are 3 inches to 4 inches below the string line set at finished grade. This is a critical dimension. Installing the spill buckets too low will make it impossible to connect them to the multiport cover. As shown in the drawing, the riser length should be the distance measured from the finished grade string line to the top of the tank or manway bung, minus 22.5 inches. 19 inches for the spill bucket height, plus 3.5 inches for the multiport cover. Follow standard industry practices for installation of the fill and vent risers. Once the risers are installed, install the P761 spill buckets onto the appropriate riser. The P761 spill buckets are manufactured with a factory machined thread, so there is no need to install a face seal adapter. Double check that the riser lengths are correct by measuring the distance from the top of the spill buckets to the string line and ensuring that it is within the proper tolerances. Once this measurement is confirmed, it is a good idea to remove the spill buckets and store them until the multiport cover is installed at a later date. This will prevent the buckets from sagging during the installation process. Cap off the fill and vent risers until the spill buckets are reinstalled. Follow tank manufacturer's instructions for completing the installation of the sump base and riser sections. Prior to installing the Fibertide top hat, sand the top 2 inches of the sump riser and then carefully clean off the fiberglass residue with acetone. Using a heavy grit sandpaper, vigorously sand the bonding channel on the underside of the Fibertide top hat and clean with acetone. Using a caulk gun, install a thick bead of the supplied SL1100 caulk into the bonding channel. Carefully place the top hat onto the sump riser section and press down until the top hat is fully seated. Use a latex glove to run a finger around the base of the top hat to ensure that the caulk forms a watertight seal. Inspect from below to ensure there are no gaps. Allow at least 24 hours of cure time before water testing or putting any pressure on the top hat. While not shown in this instructional video, OPW also recommends fiberglassing the top hat joint using our STH FGK fiberglassing kit to ensure a watertight seal. Follow standard industry practices for backfilling the fill sump area to allow for the concrete tank pad to be poured. Cover the tops of the multiports with a filter material to prevent any damage to the multiport systems during the backfilling process. Once backfilling has been completed, install the watertight shroud platform onto the top hat and position it around the 2 spill buckets. Turn all T-handles to the closed position to ensure that the platform is tightly secured to the stainless steel ring on the top edge of the top hat. The shroud boots can now be installed onto the shroud platform using the 14-inch diameter band clamps. Simply slide the shroud boot with the bolt holes facing up onto the shroud platform openings and rotate the shrouds until the holes align with the holes on the top edge of the P761 spill buckets. Once the shroud boots are properly aligned, install the band clamps at the base of the shroud openings and tighten the nuts on the band clamps to secure the boots to the platform. Once the shroud platforms are installed, the FO100 multiport cover, frame, and skirt assembly can be installed. Place the multiport cover into the FO100 frame. It is a good idea to clean and lubricate the frame prior to installing the multiport cover so that the cover fully seats down into the frame. Position the cover, frame, and skirt assembly on top of the pea gravel so that it is directly above the top pad. The ports on the multiport should be left open at this time. The top of the frame should be level with the finished grade string line. Rotate the cover and frame until the open ports are centered directly over the spill buckets. The spill buckets must be bolted to the multiport prior to pouring concrete. This will prevent the frame from moving during the installation of concrete. If this step is ignored and the frame is not properly aligned with the spill buckets after the tank pad cures, it will be necessary to break concrete and reinstall the frame. To properly connect the spill buckets, position the holes on the top edge of the spill buckets and shrouds within the port openings and drop the black cast iron clamping rings into place above the spill buckets. Using the 4-inch carriage bolts and nuts that come with the clamping ring kits, bolt the spill buckets to the clamping rings installed in the port openings. It will be necessary to remove the covers after the pad is poured, so do not over-tighten the nuts at this point. If the top edge of the spill buckets are more than 4 inches below the top of the covers, it may be necessary to use the longer bolts supplied with the kits to help raise the buckets. Once the spill buckets are properly connected to the covers, both the fill and vent port covers and the inspection port cover should be installed. Apply white lithium grease to the gaskets of all covers prior to installation. OPW recommends the use of white lithium spray grease. If installing sealable port covers, make sure that the levers are fully depressed after the covers are installed into the port openings. Prior to pouring concrete, the multi-port covers and frames should be covered by plastic sheeting and tape to prevent damage. Failure to follow this step may result in damage to the multi-port cover surfaces or the cover gaskets. This type of damage will not be covered under warranty. Simply cut plastic sheeting to the same diameter as the multi-port frames and tape the sheeting onto the top outer edge of the frames. Once this is completed, check to ensure that all frames are level with the finished grade string lines. Follow standard industry practices for installing rebar and pouring the concrete tank pad. Use appropriate trowels to carefully finish the concrete around the frame. The top edge of the frame should be level with the concrete tank pad. Once the tank pad is fully cured, the plastic sheeting and tape can be cut away using a razor knife. Final steps. Number 1. Remove the clamping rings and the multi-port covers. Install drop tubes and the required EVR, adapter fittings and dry brakes into the spill buckets. Number 2. Install leak detection sensors. The sensor tube should be installed directly below the inspection port located in the multi-port cover. Number 3. Clean the frame to ensure that no concrete or residue is on the mating surface where the cover seats. Lubricate the frame and the multi-port gasket and reset the cover into the frame. Reconnect all bolts to the clamping ring. If installing a spill bucket with a drain valve, the drain valve chain should be attached to one of the 4 bolts. If you have any questions about this Fibertide multi-port installation instructional video, please contact OPW Technical Service at 1-800-422-2525.
Moving on into section 8, we cover the replacement covers for our steel multi-ports as well as our adapter ring. I said I was going to give you highlights in this video, but this is the one section where the best source of information for you is directly in this manual. So I'm showing you here is depending on the style of manhole cover you have, whether it's A or E or whichever of these styles, you want to locate the correct form in this book. This is the best way that we have to get the dimensions that you need for some of these custom multi-ports. Now, lots of these that were done out in the past were built very custom. So it's difficult for us it's impossible for us to know if those dimensions are correct. If you go to this form, it will give you everything you need as to how to get those dimensions and what you are measuring. That's the best way I can tell you to do it. Moving on into the adapter ring. The adapter ring is made if you want to take one of these old bolt down style multiports and adapt that into our Rotolock style. This kit has everything you need in it except the anchors to anchor that into the concrete. Depending on the situation, what you have out there, we didn't want to try and guess at what anchor might be best in any given situation. So everything is needed in this except the anchors. Those must be picked up and shopped for on your own. Section 9 covers our different styles of water shrouds for these multiports. And as you turn in your manual there, you'll see that the first one is our multiport water shroud. We refer to this as our trash can style because that lid simply sits on top of the tank sump. And while it does provide protection from any rainwater that might fall down, it doesn't provide significant enough water protection for any kind of groundwater. Going on to the next one where you do have a bit more support. This is our Testable multiport water shroud. You'll test this similar the way you do our double wall spill buckets. You'll pull a vacuum to minus 15 inches of water column, and it can fall to 10 over the course of 5 minutes. Once you've completed that test and you don't have any, and you have less drop than 5 inches on the water column, that testable shroud has been tested and can be passed. And lastly, our bolt down multiport water shroud. This is our most protective against water. This will shed not only rainwater coming in from above, but this will also keep any of that groundwater out. This is our most waterproof water shroud, which covers section 9. Sections 11 and 12 will focus on the 61 SO and the 71 SO. We're going to get more in depth in the installation of both of these, but I did just want to briefly point out the difference. So the 61 SO still uses the same valve body as the 71 SO. The biggest difference is the installation practice. The 61 SO does require an epoxy that when used must have 24 hours to set. So whenever it's time to put in that valve, if you're up against a wall, you're going to have to wait that 24 hours for the epoxy to set. The 71 SO doesn't require any of that epoxy. It can be installed immediately after cutting and setting it to the right height. If you do have some 61 SOs out there on your shelves that have been out there for a long time, very good chance that epoxy has gone bad. We do recommend a Permatex cold weld to replace that, or a JB weld in a pinch. So with that, I'm going to flip it over to your favorite and mine, Chuck Leeball, for a 71 SO installation demonstration.
Hello, my name is Chuck Leeball. I'm a below ground product manager here at OPW Retail Fueling. And today we're going to go through the installation, preparation, and measurement for a 71 SO installation into an underground storage tank system. So for today's purposes there, we're going to be using our simulated cutaway tank that we have up here to do the measurements and the actual final installation of the Silverfill valve. So today we're going to step you through all the different tools that you'll need to do the installation. We'll actually just show you what comes into the box and removal of the overfill valve and all the different components that you get with the 71 SO overfill valve. And then we'll show you how to do the very specific measurements using this tank setup as an example to help you be able to do this in the field when the tank is actually buried under the ground below you there. So when we're complete with the whole cut and measurement of the system there, we'll take the valve over here and reinstall that into our cutaway tank and demonstrate how this would get installed after we complete the installation and preparation of the valve. Today's video is really just a supplement to help as an aid to installing the Silverfill prevention valve. I can't stress enough that you really must follow the installation guide. It's part number H15524PA, and this comes with every one of our 71 SO overfill prevention valves. Today, during our demonstration here, we're going to be using the 95% cutoff method over there, so the valve cuts off at 95% in the tank. But when you're doing your installation in the field, please check with your local, state, and national authority having jurisdiction to find out what the codes are that you must meet in order to install this overfill valve correctly.
Today's demonstration video is for a 95% cutoff, but this can be easily adjusted for any desired tank capacity. Contact the authority having jurisdiction in your area, as well as review the local, state, and national codes for the shutoff requirements affecting you. Also, take into account other site-specific considerations affecting the shutoff, such as extreme tank tilt. Today we are installing a non-testable overfill valve. A few are installing the testable 71SO valve. Please also see the supplemental video, as this has slight modifications to the upper tube calculation, as well as demonstrates the testable feature installation instructions. Now we're going to walk you through the measurement calculation for the upper tube. This can seem complicated at first, but we will walk you through an example on our test setup and show you how this can be easily done if you have the proper materials and follow our guide and worksheet. First, locate the tank calibration chart for where this will be installed. This will tell you the dipstick depth for the actual volume stored in the tank. So for instance, a 10,000 gallon tank does not actually have a total capacity of 10,000 gallons. In our example, a 10,000 gallon tank actually can store 9,696 gallons. Note the actual maximum volume in the tank and mark the corresponding dipstick value in the Y location of the worksheet. Next, calculate the desired shutoff volume by multiplying the actual maximum volume of the tank times the desired shutoff percentage. In our case, we will multiply the 9,696 gallons times the 95%. This gives you a desired shutoff capacity of 9,211 gallons. Then locate the closest dipstick reading for the shutoff volume on the tank chart. Select the volume next lowest to this amount as a safety factor. Write the corresponding dipstick reading for this amount on the spreadsheet as the X value. In this example, this X value would be corresponding to the 9,204 gallon dipstick reading of 82 1/4 inches. Subtract the X value from the Y value in the worksheet to capture the Z value. In our example, we will be subtracting 82 1/4 inches from the 91 5/8 inches, and this gives us 9 inches 3/8. Subtract 2 inches from this, and you will have the upper tube depth inside the tank. For our example, this will give us 7 inches 3/8. This must be at a minimum of 6.5 inches to allow a workable clearance for the float arm in the tank. If our calculated value is greater than this, then use the calculated value. If it is less than this, use 6.5 inches. Since our value today is 7 3/8 inch, we will use that instead of the 6.5 inches. Next, measure the distance between the underside of the top of the tank to the sealing surface for the A value. For our case, we are using a 2200 spill container, and this includes a built-in face seal adapter as our sealing surface. Taking a measurement from the underside of the tank to this safe face seal adapter surface gives us 13 inches. Other spill container models, such as the 2100 or the single wall edge, would require a separate face seal adapter for vapor tight systems. So you would make a measurement to the top of the face seal adapter in this instance. If this is a non-vapor tight system installation, the overfill valve may be installed at the top of the nipple below the fill adapter. The measurement then would be to the top of the nipple in this situation. Again, this is a non-testable overfill valve installation, so we will add the A value to the upper tube depth identified earlier and make sure that this is greater than the 16-inch minimum value required. This ensures that we have enough room for the bend in the tube to operate correctly with the valve. 7 3/8 plus 13 inches in our example is 20 inches 3/8, and this is greater than 16 inches, so our upper tube length value today is 20 inches 3/8. Next, we will walk you through how to cut the upper tube to the correct length. Attach the tape measure to the seam where the upper tube is attached to the valve body. Locate the measurement from the upper tube length we determined earlier and mark the valve body in this location. Next, move the band clamp included in the installation packet to just below this marking. Make sure the band clamp is square to the tube and tighten this down. Using a fine-tooth hacksaw, cut the tube using the band clamp as a guide. Rotate the tube as you cut it to ensure a square cut and reduce any runout. Once the tube is cut, remove the band clamp. Using a half-round file, remove any burrs from the cut tube, and then finish this with an emery cloth or a fine-grained sandpaper. Clean any debris from the inside of the tube with a cloth, but ensure the debris does not fall into the valve mechanism itself, as this could cause damage. We will now show you how to attach the inlet tube to the upper tube. Remove the inlet tube box from inside the 71SO box. Apply black moly grease to the inside of the upper tube and to the seal on the outside of the inlet tube. Press the inlet tube squarely into the upper tube until it is flush to the top. Be careful not to press this in at an angle or the seal may become cut and lose its ability to achieve vapor tightness. Next, remove the drill guide from the 71SO tool CT kit. Attach the guide to the inlet tube by identifying the keys on both the guide and the inside boss of the inlet tube. Tighten the set screw so that this is held flush and square to the inlet tube. Remove the drill bit from the 71SO tool CT kit and ensure that the stop on the bit is between 1 3/16 to 1 1/4 inches. This ensures that the drill does not penetrate through the inlet tube and create a leak path on the overfill valve. Drill the 3 holes using the drill guide to stop the bit. Be careful not to move the guide between drilling each hole or they may not align during the assembly. Remove the drill guide and dimple the first hole using the dimple tool included in the installation toolkit. Before dimpling any remaining holes, apply a small amount of black moly grease to the screw threads and thread in the first screw. This helps align the remaining 3 screws. Using a torque wrench, tighten the screw between 20 and 35 inch-pounds. Repeat the dimple and screw installation for the same manner for each of the remaining 2 holes to complete the upper tube assembly. Next, we will show you how to assemble, calculate, and cut the lower tube. Remove the protective cap from the bottom of the valve body. Clean and remove any debris, and apply black moly grease to the O-ring, as well as the threads on the valve body and the lower drop tube. Carefully thread the lower drop tube onto the valve body, making sure not to accidentally bend the upper tube as you would do this process. If needed, apply a strap wrench to the welded seam to tighten the lower tube past the O-ring and snug to the valve body. At this time, a pressure test can be applied to the valve by plugging the lower and upper portions of the valve and applying a maximum of 10 inches of water column to ensure that it is vapor tight. To cut the lower drop tube, measure the bottom of the tank to the drop tube sealing surface location. Consult the local authority having jurisdiction for the cut angle and the distance required from the bottom of the tank and subtract this from the measurement. For this case, we'll use 6 inches as a maximum distance and cut this at an angle that does not exceed the 6 inches. Using a fine-tooth hacksaw, cut the lower tube at the desired marking. Again, use a half-circle file and fine sandpaper to remove any burrs from the bottom of the tube. Clean any of the debris from the inside of the tube with a cloth, but again, ensure that this does not fall into the valve mechanism itself. The valve is now ready to install into the underground storage tank.
So here's our fully prepared 71SO overfill prevention valve that we completed through all the measurements and the cutting in the laboratory. And the next step that we're going to show is the installation of this into our cutoff tank system that we have simulated here. Now, of course, the bottom of this tube is much smaller than what you guys will have likely in the field, but for our purposes here, this will actually fit inside of our simulated cutaway tank over here in this environment. So the first step that we have is to apply the O-ring to the underside of the inlet adapter, the blue inlet adapter here. So you simply move that O-ring and you stretch it around the top of that inlet adapter and roll it over underneath like this. So the next step after that is to remove the rubber band around the float arm, and then I would suggest lifting up the rubber band, the float arm, to make sure that it's operating correctly. So as you lift up the float arm, you should see the valve move on the inside, past the protective bend, and into where the flow of the fluid would be during a drop. After that, you should inspect the riser to make sure that there's not a lot of like scale of rust inside of the riser or overspray from the tank inside of it, so that's in good condition inside of there. If there is a lot of scale or overspray, please clean that out before installing the 71SO into that riser area. Now the 71SO is ready to install into the underground storage tank. So when you get ready to install this, hold the float arm flat against the valve body like this and begin to insert the lower tube into the spill bucket and then into the riser. As you drop this past the opening in the spill container, you can let go of the float arm so it rests out and just start dropping it into the underground storage tank. Once the valve gets past the riser into the tank, you'll see that the float arm extends out past and is no longer flat against the valve body. Once it's installed too, you'll want to orient the float arm to be along the length of the tank. That way it ensures that there's nothing within 14 inches of the valve so that the float arm can operate freely when the fuel rises and lifts it. You can do this by positioning the protective bend on the inside of the overfill valve to the lengthwise position of the tank. So the purpose of a jack screw kit is this fits above the overfill valve and below the nipple for the inlet adapter. And it's 2 plates that are separated by 3 screws that expand and compress these plates out, thus compressing the O-ring that's on the underside of the 71SO to the face seal adapter and ensuring a good tight seal for vapor tightness. You'll see that there's 2 parts, a lower plate that has holes that have an indentation into it but not drilled all the way through, and an upper plate that has threads screwed into the upper plate there that the screw passes through. For our purposes today, we're installing this inside of a cast iron based spill container. So we use the cast iron base jack screw kit 61 JSK-44CB. If you have a composite based spill container, you would use the 61 JSK-4410 for that application. To start, take the lower flange and place this on the top of the 71SO blue inlet adapter, as such. Next, thread the screws into the upper part of the top plate. You can tell the upper part of the top plate is it has an indentation cut into it. This will actually fit on the inside of the nipple to get good grip onto it. So the 3 screws can pass through here. Once you have a few of the threads exposed beneath, you can apply the Loctite sealant to the upper parts of the threads. And this will ensure, once we have this torqued, that you'll have a good, stable, and non-moving jack screw kit, so you'll be able to maintain that vapor tightness. So take the 3 exposed parts of the screws and place those into the indentation of the lower plate, as such. And then you put thread sealant on the inlet adapter pipe nipple on the threads and torque this into the spill container. The fill adapter pipe nipple should be torqued between 125 and 250 foot-pounds. But in reality, this needs to be progressively less from the top of the tank through the top of the assembly there. This allows you to be able to remove that part of the assembly without loosening up any of the parts below that. So if you have a progressively higher torque below, you're allowed to be able to remove one of the upper pieces without spinning off anything unintentionally below that. That could be buried directly into the ground. So the inlet adapter can be, nipple can be tightened to torque by using the TC400 torque cap. This threads on to the upper part of the nipple. And then it can be tightened to spec using the 61 SA tool that fits around the ears. And torque can be applied to the lug at the top of that tool. So you torque this to the desired amount, and when complete, you can remove the torque cap by doing an impact in the opposite direction to loosen the cap from the nipple adapter, as opposed to unthreading that nipple from the base. So it would be a quick jerk, and you would break free the cap, and you can remove the cap from the inlet nipple. As you can see, the jack screw kit is still loosely installed between the inlet nipple and the overflow valve top. Next, we need to install the 61 SALP to the inlet nipple inside of the spill bucket. Using the 61 SA tool and a torque wrench, tighten the 61 SALP to between 90 to 110 foot-pounds of torque. Finally, using a hex head tool and a torque wrench, tighten each of the 3 jack screw kit bolts to 3.5 to 5 foot-pounds of torque to ensure even and tight compression of the O-ring sealing the 71SO. For non-vapor tight applications, the 71SO is often located between the inlet adapter and the nipple between that and the spill base. So install the 71SO through the nipple connected to the spill container base, and then attach the inlet adapter to the top of the nipple. Now that you have the 71SO correctly installed and oriented in a tank, you will need to complete any tests and measurements required by the local authority having jurisdiction, as well as any state or national codes that apply to your region.
Next, install the warning plate inside of the spill bucket. Bend the 3 warning plate ears down, and then slide the tie wrap over the warning plate ears, and position the warning plate against the riser pipe approximately 1 inch below the adapter. Tighten the tie wrap securely. The valve is now fully installed and in operating position.
Thanks, Chuck. In addition to that, because we do have a new addition, I did just want to reference everyone to our new app. There is a really cool tool within this app. If you click on the OPW app there, we do have a really nice 71SO measurement tool that, similar to what Chuck just showed you there, doing the math and those entries, you can actually go to Tools within our app, and the very first entry up there says 71SO or 71SO-T calculator. And that tool right there will walk you through all of the steps with your input from your tank charts to give you an exact place to cut to install that 71SO that's going to be correct every time, whether you're installing to 95-degree final shutoff or 95% initial shutoff. Section 13 touches on the 61T drop tube. Now the 61T doesn't actually have any overfill prevention to it, but while we discuss how to cut that and how to measure it from the bottom, this also applies to the other overfill valves as well. So it is mandatory that the bottom of that drop tube be within 6 inches of the tank bottom. You can either cut that straight across the bottom, or you can cut it at a 45. Now, if you cut it at a 45, like we have the 71SO demonstration piece here, you will measure that 6 inches from the top of the cut, not from the bottom. So if you were at 6 inches from the bottom, this would be at 6, and then you would have the additional below that. It is required that it must be within 6 inches of the tank bottom. Section 14, which focuses on tank bottom protectors, or this unit here. These aren't as commonly seen anymore these days. If you do come into contact with one of these and you pull out an overfill valve and this is all attached to the bottom of it, please put it back. Someone at some point made the decision that it was required to protect the bottom of that tank, so, because it either is a single wall fiberglass tank that doesn't have a striker plate, or some other situation that they deemed it necessary for it to have this tank bottom protector. Whenever you're installing a drop tube or overfill valve and there is one of these, you are still measuring that final dimension to the bottom of the tank. It is not to the top of the tank bottom protector. So again, if you ever see one of these, just make sure you put it back and ignore this whenever you're taking measurements for your overfill or drop tube. Section 15 covers our jack screw assemblies, their different uses and different applications, as well as our face seal adapters. So as Chuck explained, the jack screws exist so that they can expand and put pressure on this O-ring on our overfill protection or drop tube, and that's going to seal off any emissions from getting out around this overfill valve from inside the tank. Now you'll notice that all of these look a little bit different. This is our 61 JSK-4410, the 4410. This is to be used in the composite bases of our 2100 series bucket. So the 61 JSK-44CB, this one will be used in our cast iron bases, whether it's a 2100 series with a cast iron or some of our other cast iron products that we've used already in this presentation. We also have the 61 JSK-4RMT. Now the 4RMT, the remote, that's going to be used for our remote fill applications. Whenever you've got your fuel line coming from a remote location into the T inside a sump, where your extractor T will be, where you're actually dropping into that tank, this will be accepting of the fuel flow in to allow it to drop down into that overfill protection. Now we do make this in a 71 JSK-4RMT as well as the 71 JSK-44MA. Now both of the 71 JSK versions are rated up to E85 with those higher ethanol blend fuels. So your E20s all the way up to E85 would be the 71 JSK-44MA or the 71 JSK-4RMT. A note when installing any of these jack screw assemblies, you'll notice whenever we were doing the installation of the tank top up, we had everything tightened before we even really discussed this. The jack screw kit should always be the last thing that you tighten and the first thing that you loosen. That way everything is in a rigid stuck place where nothing else is going to move, and then we can compress this to engage the seal on the 71SO or 61SO. Likewise, whenever we remove any of these parts, or we're going to get down to that, we want to loosen the jack screw assembly first, so we're not putting unnecessary stress on any of the gaskets or seals whenever we're trying to turn a very tightened system. So you just want to remember that this is the first thing that you loosen and the last thing that you tighten. Also in this section, we cover our face seal adapters and their uses and wear. Now, I've already said some of this stuff before, but these are critically important to EVR compliance, so I just want to make sure that we get a good understanding of this. This is the taller version, the FSA-400. It is 4 3/8 of an inch tall and goes on top of the riser, and that's what gives a good seal for our overfill prevention to prevent vapors from getting around. The tall one is only, again, used in the composite base. The FSA-400S is used under our cast iron bases of the 2100 series. It is also used as the placeholder for our Edge 1 or our single wall 3100 series. These are needed in the applications that we just discussed, as well as their use in the 62M monitoring well or probe cap. You would use the face seal adapter as well to get a good seal on that cap. Moving right along into section 16, we're going to be covering our 61 SALP fill adapter, as well as our 61 VSA vapor swivel adapter. Okay. Now, both of these are to install. If you remember back to whenever we did all the spill buckets on the tank earlier, are going to be the 90 to 110 foot-pounds, and they're all going to be installed with that 61 SA tool. A really important note here, whether you're servicing one of these or doing an EVR swivel test on them, or if you're taking them straight out of the box, something that I did want to note is on each one of these, we stamp the manufacturer's date, which this one's been in our showroom for a while. This one's 0609. And also, we laser in a serial number onto each one of these parts. That's for the fill and vapor recovery adapters. If ever you have an issue and you need to call tech support or customer service, it's very, very helpful for you to already have this information on hand so that we can go ahead and start processing which way we need to take your request. Section 17 focuses on the caps for our adapters, as well as the 62M monitoring probe cap. These should look very familiar to you. These are our 634 TT and our 1711T. You see these on the fill adapter inside spill containers, and you see the 1711T on the vapor adapter. Both of these caps come in a low profile version. That changes the part number from the traditional to a 634 or 1711 LPC, which is low pro cap. And then lastly, it also covers our 62M, which I told earlier requires the use of that face seal adapter. That is how you get that vapor tight seal when using the 62M for your probe. So do be sure to use that face seal adapter, that FSA-400. We recommend that you check the seal inside of each of these caps once a year, just to ensure that they're holding up, that you're not seeing any debris on there, that everything is holding up in good shape. They are slightly different seals. For the fill adapter, for the 634 TT, you're going to need an H15005M. And for the 1711, that number is H10886M. Section 18 serves as a summary of all of the installation tools that we've needed so far to this point, and as well, there's one left that we haven't yet covered. We started with the 61 SA tool. We use this for a lot of things. This is used for the 2100 series spill bucket installation. It's used for the 3100 series single wall style spill bucket. It's also used on the TC-400. It's used on both our fill and vapor adapters, as well as our face seal adapters. So we use this tool for a lot of things. The 3100 tool serves as the installation tool for our newer style spill buckets. You'll use this one for our 2200 style and our 3100 double wall edge. This has the provisions in the bottom for our 3-bolt flange, which makes a number of other processes easier. The TC-400 cap, this is used again in junction with the 61 SA, and you'll use this whenever you're installing nipples and risers. This is going to thread right over the top. You put your 61 SA tool and you'll tighten, and this will easily pop off. And lastly, the 200-459, this is our static test tool. It's going to test our swivel fills and adapters, and we'll go over that in just one second. Section 19 covers our 723 pressure vacuum vent. I'm going to share just a couple of installation tips with you, as well as our recommended maintenance on this product. So first, you're going to install to 35 to 50 foot-pounds for the 723. And whenever we install it, we're going to use an oil and gas resistant non-hardening pipe dope, some kind of thread sealant. We want to keep all those vapors where we want them. This is an aluminum adapter, so whenever we install this, we're going to want to use a strap wrench. There are provisions here for a large jawed flat-sided wrench, but we want to keep the teeth and the pipe wrenches off of this aluminum adapter. Moving into maintenance, it's very, very simple with the 723. You can pop this cap off. There's a main screen here which covers our pressure vacuum poppet. And when you pull this out, you do want to look down there, see that it's clear, free of debris. You just want to test that poppet, make sure that none of those gaskets are sticky or there is anything in them and they're working properly. And make sure that you're going to seat it down on a clean gasket. Once we replace the top, we're just going to want to spin off the 723 from its metal adapter. That way we can pull the bottom screen, we can check it out, make sure it's intact, make sure it's clean. Everything is looking good inside there. Our O-ring is intact, and then we can just re-grease and then reinstall our 723 vent into proper working condition. Now technically in this book there is no section 20, but we do have an appendix in the back that has a lot of really, really good information in it. In the appendix you'll find our EVR product registration card, our product warranty, and there's some really good reference tables and installation checklists, as well as some carb protocol back there. First, I do want to turn your attention to the EVR Phase 1 component installation torque specs. Throughout this video, I have lobbed a lot of numbers at you, and this is the easiest way to get all of those numbers in one place. Should you need to double check to make sure that something is being properly installed, page 221 of the manual does provide all of those installation torque specs. Just behind that, we do have some maintenance activities that show what needs to be checked and when. This can be helpful whenever you're doing your annual maintenance of the EVR UST system. Also in the back of the appendix is the test procedure for the TP-201.1b swivel test procedure, which I'll show you right now. As I mentioned, in the back of the manual we have the test procedure for the static torque test, which is required for all fill and vapor adapters under EVR. The purpose of this test is just to make sure that these swivel adapters are testing tight and that we're keeping all of the vapor in like we say we are. The first thing we're going to do is get access to our fill and vapor adapters so that we can remove the dust caps and check to see that they're in good working condition. Some people do have a test cap that they like to use just for this purpose, but either way you just want to make sure that the seal is clean, there's not a bunch of lubricant on there where this cap is going to slide. Next, before we start the test, we're going to want to put our cap on to swivel at least 360 degrees. That means you can either turn this all the way around one time or you can do it 3 times, but we just want to make sure that this is swiveling a proper 360 degrees. Now there's 2 tools that you can use to do this test. You can either use the 61 SA, which has provisions to go right over the top of that dust cap, or you can use what I mentioned earlier, the 200-459, which is a tool that was made specifically for this purpose. It'll slide right over the top of your dust cap and it'll give you a place to put your torque wrench. So from this point we're going to make 3 marks that are an even 120 degrees around the spill bucket. You can just make this with a simple black mark on the snowplow ring of your spill bucket. Each one of these will be the 3 data points that we need to get our torque test average. So first you're going to put your torque wrench in, get it lined up to the first mark, zero out your torque wrench, and you're going to slowly apply pressure until you start to feel a turn. As soon as you feel that first movement, you look down and you record that torque value right here in the first box of labeled torque 1. Next, you'll continue moving the swivel adapter all the way around until it reaches the front of the second mark, and then you'll put your torque wrench back in, zero it out, slowly start to turn until you feel that first movement. There again, you'll look down, take that torque reading, and you'll write that down in torque 2. Then you'll repeat this process one more time from the third line and write that first movement torque reading in torque 3. Once you've got your 3 torque readings, you need to take the average of those 3, and the average needs to be below 108 inch-pounds. If it is not below 108 inch-pounds, the fill adapter or vapor adapter that you're testing does need to be replaced. And that concludes the OPW UST EVR training. Thank you for sticking with me. I know this is a little bit longer video than you're used to, and listening to me talk about torque stack and saying face seal adapter 10,000 times. If there is any questions that you have from this, please feel free to reach out to our tech support or customer support centers. Have a great day.